So, what we finished off with Friday was solving quadratics. We're solving quadratic equations. Now, one of the ones we came across, we had a little bit of an issue because we were trying to find the square root of negative 5/2. And both the calculators said that this was an error, that it does not work. And really what we're trying to get at is finding a number when multiplied by itself, you get a negative number. Now, in the simplest case, we can just use 1. Now, 1 times 1 is, and if we did negative 1 times negative 1, we get, because whenever we multiply a number by itself, we don't get a negative, we get a positive. And that's really why we can't take the square root of negative 5/2, because it does not work. We don't have a number when multiplied by itself that gives us a negative. So we're really trying to look for a number times itself that gives us negative 1. Well, we're going to imagine a number. We're going to call it I. When multiplied by itself gives us negative 1. And if we wanted to find I itself, well, we would take the square root of both sides, and the square root and square would cancel. And it'd be telling us that I, this number, when multiplied by itself, gives us negative 1, is really the square root of negative 1. And that actually is it. I is the square root of negative 1. This imaginary number I is, by definition, the square root of negative 1. That's how we can actually take the square root of negative, is if we have this here. So when we look at this first one here, the square root of negative 25. We can try this in the calculator. We can say second square root, negative 25, and it'll tell us domain error, because there is not a number, a real number when multiplied by itself, that gives us negative 25. Now we can break this into two parts, because we can say that the square root of negative 25 is the same as the square root of negative 1 times 25. And according to our properties of radicals, we can break those apart and say the square root of negative 1 times the square root of 25. Well, we know what the square root of 25 is, 5. And as we just said, I, by definition, is the square root of negative 1. So the square root of negative 25 is 5i.
So it's just so the next one it would be
Now we've already seen the 30xs will not take the square root of negative 72. But what do we know the negative is going to come out as? Well, the negative is going to become I. So if we take that negative out, because the negative is going to come out as I, and what that leaves us with is the square root of 72. The negative comes out as I, leaving us with the square root of 72. Well, the 30xs can take the square root of 72. Square root of 72 is 6 square root of 2. And if we multiply these back together, we would multiply the 6 and I, giving us 6i square root of 2.
I don't know what question that is. Why?
Okay. So the next one's negative 5 times the square root of negative 9. So the square root of negative 9, well, we know what the square root of 9 is. Square root of 9 is 3. And the negative would be our. Now we do need to multiply these two together. Negative 5 times 3i is negative 15i. That's the answer. Because we're simplifying the radical itself. Because for the first, this one before it, b, because we're really looking at it as the square root of negative 1 times the square root of 72. Well, square root of negative 1 is I. Square root of 72, we found out to be 6 square roots of 2. Multiply those two together. The square root of 2 comes down, we do 6 times I, giving us 6i. Here we have the square root of 5 times square root of negative 9. Square root of negative 9 gives us 3i. We can multiply those two together, gives us negative 15i. Figure all that out. Now, negative 5 seconds square root negative 9. Graphing calculator will do that there for us. Because negative 4, square root of negative 4, well, the negative is going to come out as square root of 4 is 2i. Square root of negative 12. Is 12 a perfect square? Now, if we look at the last two we plugged in, square root of negative 4, 4 is a perfect square, yes? The one before, we took the square root of negative 9. 9 is a perfect square. The graphing calculator can handle those nicely. Since 12 is not a perfect square, it's going to give us the decimal approximation of it, because it's going to be a non-repeating, non-terminating decimal. So, we want it in simplest radical form. So if we want it in simplest radical form, we know the negative is going to come out as what? I, which is really just leaving us what? The square root of the 30xs. We'll deal with radicals. Second, square root 12 is a square root of 3. So we use our understanding of I, that this negative is going to come out as I. And then we can use the yellow calculator to simplify the square root of 12 part and get our answer. Questions on this here? Negative square root of negative 36. So we still have the negative on the outside. What's the square root of 36? And the negative part is going to become I. So it's negative 6i. Since 36 is a perfect square, we could have just plugged that in the calculator and it would have told us the answer. Questions on this here? Is 54 a perfect square? No. We do know the negative is going to come out as I. Now we do need to find the square root of 54. Square root of 54 is 3 square roots of 6. Because for us here, I think that's, yeah, 3 square root of 6. Because it's 9 times 6, square root of 9 is 3, and we have our 6 left over. Now it's not, huh? Yeah, so we'll do the 2 times 3i, which is 6i square roots of 6. Now we could have typed it in the calculator as 2 second square root 54. which would have given us 6 square roots of 6. We put the I back in, 6i squared is 6. Because the 30xs is very nice, especially with simplifying radicals, as long as what's inside the radical, these roots even, or these square roots, is not negative. Questions on this here? What do we think of I so far? It's not too bad. And for the most part, we can treat I as we would a variable, but unlike most variables, I has a definite value. I, for the most part, except for one other case that I can remember off the top of my head, I is not used through most of the rest of our solving. Because when you're solving linear equations or solving, we've used A, B, C, D, E. We've used almost every letter. We avoid I, because I is defined as square root of -1. The only other place that we do use I is in vectors, because I is the x component and j is the y component. So vectors is the only other place I does show up normally. Or not in Algebra 2. Actually, matrices, they do use I and j for rows and columns, but we might talk about those later. Now, I, we're talking about powers of I. And as we've already said, I is the square root of -1. Now, I squared, we're going to multiply it by itself. Well, that would be the square root of -1 squared. And the square root of -1 squared is -1, because the square root and square would cancel, leaving us with just our -1. Okay? Nothing too fancy at this point. I cubed. -1, square root of -1. Now, yeah, so I squared, well, I is the square root of -1, and we're squaring it. Square root and square would cancel, giving us -1. I cubed, well, that's the same as I squared times I. We're just taking the previous one and multiplying it by I again. Well, we know I squared is -1. So we're having -1 times I, which is -I. I'm just going to keep doing these here for a little bit. I to the 4th. Well, we can say this is I to the 3rd times I. We already found out what I to the 3rd is. It's -I. Well, -I times I is -I squared. Well, what is I squared? We get -1, and -1 is 1. Questions on this so far? Well, we really haven't done a lot yet. I'm going to keep going. I to the 5th. Well, that'd be I to the 4th times I. Well, what is I to the 4th? One. 1 times I gives us I. Okay. I to the 6th. We can say that's I to the 5th times I. Well, I to the 5th is just I. So it gives us I times I, which is I squared, which is negative 1. So I to the 5th gave us I to the 6th gave us the same thing as I squared, which gave us negative 1. Let's see what I to the 7th is. We can say that's I to the 6th times I. We said I to the 6th was negative 1, and negative 1 times I gives us negative I. Anybody have a guess at what I to the 8th is going to be? Anybody have a guess at what I to the 8th is going to give us? Because I to the 7th times I, yes? Well, I to the 7th was negative I times I, which would be negative I squared, which gives us, because negative 1. Well, I to the 8th is the same as I to the 4th, which is 1. Now, if we kept this going, what would I to the 9th be? Because it'd be I to the 8th times I. Well, I to the 8th is 1, and 1 times I gives us I, which is the square root of negative 1. This means that I to the 10th is going to be negative 1. I to the 11th is negative I to the 12th would be 1. With any power of I, it cycles through these 4 values. It's going to be one of the 4. I, negative 1, negative I, or 1 for any power. Now, we went all through that there just to kind of show that cycle that is going I, negative 1, negative I, 1. I, negative 1, negative I, 1. And it works out that for I to any power, we get 1 of 4. We either get I, negative 1, negative I, or 1. Now to figure out which one we have, we take whatever the power is and divide it by 4, because we have 4 choices. Yes? If we take that power and divide by 4 and get a decimal of 0.25, it's going to be I. If we get a decimal of 0.50, it's going to be negative 1. If we get a decimal of 0.75, we get negative I. And if we get a decimal of 0.00, we get 1. All right, let's put this into practice a little bit. Evaluate I to the 27th. So 27 divided by 4 is 6.75. So when we divide 27 by 4, we get 6.75. We are not concerned with the 6. We're focused on this 0.75. Because if we check our reference, 0.75 is negative I. So that tells us I to the 27th is negative I. Because we had 1, 2, 3, 4 options. 0.25 gives us I, 0.50, negative 1, 0.75 is negative I, and 0.00 is 1. So questions on evaluating I to the 27th? Let's look at I to the 34th. So we take 34 and divide it by 4. So 34 divided by 4 is 8.5. So now again, we're not focused on the 8, we're focused on the 0.5, and 0.5 would tell us it is what? -1. Now the 6, or here in this case the 8, what that's telling us is that we went through this cycle of 4 8 times, and then we went 2 more. So we went through it 8 times and then went 2 more, which gets us -1. That's it. Questions on this here? 47, I to the 47th. Well, we can take 47 divided by 4. I think it's 11.75. Might be wrong. Nope. Number 7. 65 divided by 4 is 16.25. Because we have our 0.25, which tells us this is indeed I. I to the 1040 is it's going to be 1. Because if you divide in the calculator and it gives you just a whole number, it doesn't give you a decimal, it's understood that the decimal is 0.00, so it's 1. That's it. Questions on this here? And will the calculator, the graphing calculator, do these? Yes. Second decimal will give us I. And we can do the first one that we had. I to the 27th is. Yes. Now, the last one, 1040. We found this to be what? 260. Well, it was 1. So it's telling us here we do have the 1 plus 4e negative 12i. 1 plus 4e negative 12i. What this is saying is that we're multiplying the 4 by 10 to the negative 12th. So that means we got to move the decimal 12 spaces over. So what it's saying is we have 1 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's a number that this has. And for all case and purposes, especially for the graphing calculator, this here is 0. Now the calculator, to do this and calculate powers of I, it's actually graphing the function, because there is a way to graph it to find its value. And this here is a pixel error, because it's just that small of a pixel off of what the actual value is. So it's approximating it. It's really 0, because this number is really close to 0. So it is just 1. So it does work well until we start getting bigger values or bigger powers of I, where we have to interpret this correctly, that this e to the negative 12 doesn't work. So, I mean, up to a certain point, it gives us straight values. Then we've got to interpret what the other half is. Does that make sense? But sometimes it's easier to just divide by 4 and have our choice. Any questions on any of this here? We ready for addition and subtraction?
Oh, yeah.
To add or subtract two complex numbers, add or subtract their real parts and their imaginary parts separately. And then we're going to write it in the form of a plus bi. A is the real number, bi is the imaginary part. And when we put them together, we get a complex number. So the first one we're going to look at is 8 minus I plus 5 plus 4i. Now since we're adding, we can go on and drop the parentheses. Now it said to add our real parts together. So 8 plus 5 is our negative I plus 4i is
3i.
and that's it. Questions on this here? Let's look at the next one. I'll give him a little bit of an elbow. So if we look at this one here, now these we do have to be careful with because of the negative. Because the first one stays the same. Now the next one we do have to apply the negative to it. So our 3 is going to be negative 3. Our negative 6i is going to become positive 6i. Because we have to move that negative through, because we're subtracting 3 and subtracting negative 6i. Because subtracting 3 is the same as negative 3. And if we subtract a negative, it becomes positive. 7 minus 3 is indeed 4. What's negative 6i plus 6i?
Oh,
Just 4. Because 0i is the same as 0. Questions on this here? We ready for the next part? (13 minus 2 plus 7i plus 5i). Well, we do need to apply the negative to the middle, so it'd be negative 2 minus 7i plus 5i. Well, 13 minus 2 is 11. Negative 7i plus 5i is
12. No,
not quite.
no, 11.
5 minus 7. Negative 2i.
Oh, well, I had one brain card.
2 plus 7i. So the next one, 2 plus 9i plus 11 minus I. That's it. Questions on this here?
Oh, the next page after this is homework.
Questions on addition or subtraction? We feel good with addition and subtraction? Well, after addition and subtraction, we have multiplication. Now we can distribute this out, because if we're multiplying, we're going to distribute And the first thing we're going to do is 4i times negative 6. Let's focus up here. Negative 24i. 4i times I would be plus 4i squared. Now with I, unlike variables, we cannot leave it with an exponent. We have to reduce it. Now I squared is what? Because 2 divided by 4 is 0.5, which is negative 1. Now out of all of them, knowing that I is the square root of negative 1 and that I squared is negative 1 are good to know. Because what that tells us is that we have 24i plus 4 times negative 1. Well, 4 times negative 1 is negative 4 minus 24i. Now we do want to always write it in the standard form a plus bi. Real number first, our bi number second, and we're writing our answer. Questions on this here? You want to, let's try typing the second one in. 15 times negative 1 plus 2i. 15 parentheses negative 1 plus 2i. Negative 30 minus 15i. Yeah, because if we distribute it, it'd be negative 15i plus 30i squared.
Can you type all this into the text editor?
Let me get this here. Well, the last two that we have are these two here. I'm going to do this first one by hand, because if we did it by hand, we would distribute. 9 times negative 4 is negative 36. 9 times 7i is plus 63i. Negative 2i times negative 4 is going to be plus 8i. Negative 2i times 7i, negative 14i squared. Now we can combine like terms. 63i plus 8i is 71i. Well, I squared is negative 1. Negative 14 times negative 1 is plus 14. I did move it over so that we do have our like terms next to each other. Negative 36 plus 14 is negative 22 plus 71i. I think at least one of y'all typed it in, yes? I believe we would. Questions on this here? Because again, we could type these in the calculator and it would do it for us. We're ready for the next part.